Hello everyone. So let us study the next topic, that is cables. So we've already studied about arches. The next concept is cables. So let's see what is basically a cabled structure. So you must have seen the bridges, which will have a cables like this. They are basically uh, tensile in nature, and they are tied at the ends. So basically they act like a load bearing cables. So you can see here, these are all called as a load bearing cables. So basically there is a concrete beam here, and at the ends, the beams and all are tied. The load is carried. The load of this uh, bridge is carried by this cables. Okay, you must have heard about this hanging bridge, London Bridge. So all of these, um, they're all carrying cables as such. Okay. Okay, so this is called as a cable stayed bridge, and this is called as a suspension bridge. So basically all these are like the cables which carry the entire load of this bridge. Okay, I'll show you the actual pictures of a bridge. Okay, you can see here, this is called as a cable stayed bridge. If you've seen this, okay, now see here, these are called as the towers or pylons. You can see here, these are called as pylons. And the complete entire load of this bridge, okay, it is all carried by this cable. You can see here. So this is the bridge. You can see the span here. See here. It has the highest beam, the longest beam. Okay. Now because it has the longest beam, obviously it will have maximum bending moment. So that moment is carried by this cables. You can see here, this moment is carried here, and it is at this portion. It is pulled and tied. Same thing here. From this portion, it's pulled, tension, and tied here tightly. Same thing. All these cables means now this load is carried by this cable, and in turn it is fixed at this pylon. Okay. Okay. If you want, you can see this suspension bridge also. Okay. So these are all load bearing cables. Okay. Okay, you can see here, these are all cables. You can see this is all the cables. This is called as a deck. These towers, okay, this is all made up of concrete. This is called as pylons. And again, in turn, see, this is a cable stayed bridge, and this is called as a suspension bridge. You can see all the cables are like this, suspended. Again, same thing. This is called as the deck. These are called as the pylons, and these are all cables. Okay, because they are long spanned, bending moment is maximum. So in order to control that bending moment, all the cables are tied like this. So the load falling on this is in turn carried by this cable. So it is fixed at one end, pulled, tensioned, and fixed at the other end. Okay, so this is how this is called as a cable stayed bridge, and this is called as a suspension bridge. Okay, you can see here, this is a suspension bridge. You can see the cables. So these are the members which carry all the loads. So it's carrying the load from this deck. It is transferred to this portion. You can see here, this cable through these wires, and in turn it is sent to this pylon. Okay, so these are called as cable suspension bridge, and this is called as cable stayed bridge. So you can imagine what exactly are these cables. So now what we're going to design here is, we're finding out how much is the uh, tension forces. Now obviously because it is fixed at one end, pulled, tension. Pulling means tension force. So pulled at other end and fixed at the other end. So because of this tensile strength, it is pulled, and we are going to find how much is the tension forces in this, both suspension bridge as well as in cable stayed bridge. Okay. All right. Okay. So now, what we are going to find out here is, okay. So these are called as the hangers. These are called as the cables. So what we're going to find out here is, we're going to find how much is the total length of the cable, both in suspension bridge and cable stayed bridge, and how much is the tensile forces carried by both the type of bridges. Okay, so only we're going to find how much is the forces in the cables. Okay, so the first problem is, analyze the cable under UDL acts on the entire span. Analyze this cable. Okay, see it. This is the cable, and there is a UDL acting on the entire span, or show that equation of the cable is y is equal to 4h Lx minus x square divided by L square. See, we have already used this equation. So this is the equation of the parabola. So in exam, they'll either ask you, analyze the cable under the UDL on the entire span. Only this part of the question can be asked. Okay, then it is understood that you have to take this parabolic equation, or they simply ask you the second part like this. Show that the equation of the cable is this. Okay. So first let us now sketch the cable with the UDL. So always we draw the cable like this. So cable is nothing but, again, it is a tensile wire, okay, which are clustered and tied together, and it is fixed at one end, and it is pulled like this, elongated, maintain that angle here, maintain the angle, maintain this. This is called as the dip. Now we used to call, in arches, we used to call it, we used to draw it, or just the opposite, because in arches it would be the opposite side like this, and we used to call it as a rise. Now this is called, you can see here, this exactly the center, it is called as the tip. Okay, so this is A and B, and they've told there is a UDL acting on the span. The UDL is W per unit length. Okay, this is length is L, and the UDL is W per unit length. Okay, so after a drawing sketch, again things are as usual. We'll find all the reactions. So A and B, they're treated as a hinge support. Okay, A and B are treated as the hinge support, and because they are hinge, there are two reactions: HA VA, HB VB. Okay, this is called as the dip. So the dip here is H. Okay, distance exactly the center to the C. So we name this as AB, and it is maximum bending is at C. Okay, at the center, so we'll name it as H. Okay, and the length is L. So now you can see here, because it is symmetrical, if I cut this section here and I flip this over, it is going to be symmetrical. So because of the symmetry, obviously VA and VB would be equal. Okay, so see here, downward load is W. So if it gets distributed, so W into L. Okay, it is acting downward. To stop this load, there is equal and opposite forces acting upward. That is W into L. That is upward means exactly half. So WL by 2 here, WL by 2 here. So we got V and VB. Okay, so next is, we'll use this equation, that is so summation H is equal to 0. So we know that there are horizontal forces, HA right side. Okay, again, see, this is your choice, you can put it as anyhow you want. Okay, so actually HA to the right means plus, HB to the left is minus. So any which ways, if you transfer this, so HA is equal to HB. So to make this simple, what we are going to do here is, HA is equal to HB, and that is nothing but it is equal to H. We'll take this one quantity because they are same. HA is nothing but it is HB. So we'll treat this quantity as H. Okay, next. Now we know that bending moment about anywhere in this cable at this A portion, C or B, or other than that, at any intermediate position, the bending moment in the cable is always 0. Okay, so anywhere you cut the section, so bending moment in this cable is always 0. So now, if you take the bending moment at any point, okay, so here what I'll do, I'll cut the section exactly at C, because at C there is a maximum dip. Okay, so at C, taking moment about a point where a dip is maximum, that is occurring at C. Okay, so now I'll take only AC portion. Okay, so in AC portion, taking moment about this portion. So now check to the left side. Okay, to the left side, check the forces. So it is now VA. VA is going clockwise. So VA into this distance. So I'll take this distance as X. Okay, so now this is X, exactly at this point. So it is L means complete distance, exactly at the uh, C is L by 2. So WL by 2 into L by 2. Okay, so WL by 2 into L by 2. Next, now HA. Now check this. HA is going like this. See here, VA is going in this direction, right? Okay, now HA. All right, so HA is going in the, now we have assumed it is acting to the right side like this. So it has to reach C. Now, if it has to reach C, remember always, HA will travel along the length of the cable. So if it is traveling along the length of the cable, so it is like this, force into its perpendicular distance, and it is traveling along the length. So it is going now anti-clockwise. Anti-clockwise minus HA into H. Next, again W UDL. It is again going anti-clockwise. So it is now minus W into L by 2 into L by 2, half of L by 2. So W into L by 2 is the load. W into L by 2 is load. Into half of this. So it is L by 4 is equal to 0. So when you solve this, okay, you get the value of HA. So we know that HA is nothing but H, which is also equal to HB. So which is nothing but WL square by 8H. Okay. Now let us take the bending moment at the section X. So bending moment at any section here. So, okay, I'll consider this. So now I got HA also, I got V also. I'll consider the bending moment at this section X. So now the bending moment would be VA into X, then minus HA into X, then W into X into X by 2, right? Okay, so now bending moment at this section is VA, WL by 2 into X, WL by 2 into X, so it is going clockwise. Next, HA, okay, now see here, again it is traveling along the cable length, so it is HA into Y, okay, so it is now HA into Y, then again this is going anti-clockwise. So it is now W into X by 2. So it is W X square by 2. Okay. So now when you solve this, okay, see here, go on solving this properly. Now in place of, see here, X, you have X, Y and X. Okay. So solve this. Okay. So it is X, Y and X. Now take common in this. W by 2 is common. So it is Lx minus X square. Take this, write it down like this only. Okay. Then shift this on the other side of equal to this portion and this portion. Okay. So now we'll get in terms of Y. So again, cross multiply this. Y is equal to, see here 4H by L square into Lx minus X square. So when you solve this, you'll get this equation. Okay, again as usual, here you have to take first VA, sum of all the forces. VA is equal to 0, vertical forces, summation of vertical forces is equal to 0, summation of horizontal forces is equal to 0, then moment about C is equal to 0, and finally moment, cut this section at this portion, any portion. So Mx is equal to 0. This is an important problem which will be asked in the exam. Okay. On the same lines, we have the next problem, that is a cable of 20 meter. Okay, now see here, there is a cable of 20-meter long, and the dip is 4 meter, carries a UDL of 20 kilonewton per meter over the whole span. Okay, find maximum tension in the cable, minimum tension in the cable, then length of the cable. So three things you have to find out: maximum, minimum tension, then the length of the cable. Okay, so basically all the cables are parabolic. Okay, all the cables are parabolic, so we'll always use the same equation. All right, so first sketch the cable. So you already, again in exam they'll only give you this question, so you yourself have to draw. Okay, so it's a cable of 20-meter long. Draw this 20-meter length should be like this. The cable will be parabolic, and the dip is nothing but this highest point from this portion. Okay, so the dip is 4 meter, and it carries a UDL of 20 kilonewton over the whole span. Okay, so it is only UDL here. So first, as usual, sketch this, and you can see because there is a UDL, there is a symmetry here. So because there is symmetry, downward load is 20 into 20. Okay, 20 into 20, 400, which will be carried by both of this, V and VB. So it is 400 divided by 2. So 200 upward, 200 upward. Okay, next, find find this HA and HB. Now you know that we have this three equilibrium equations. It is summation H is equal to 0, summation V is equal to 0, and moment about C equal to 0, then moment about A. As we have done in arches, the same thing we'll do here. Summation of all the horizontal forces equal to 0. That is summation H is equal to 0, summation V is equal to 0, moment about C is equal to 0, and moment about A is equal to 0. Okay, so now first all the horizontal forces. Okay, so HA minus HB is equal to 0. Then keep it as it is. Then summation V is equal to 0. So we already know that vertical forces VA plus VB is 400. Next, now we know that bending moment in, if you cut the section anywhere in the cable, it is going to be 0. So taking moment at a point where the maximum depth, that is bending moment at C, will take 0, in such a way that, okay, either we can consider to the left or to the right. The choice is yours. You can consider anywhere. Okay, so if you consider to the left, be careful with the sign conventions, or to the right, the same thing. Okay, so now at to the right. So if I consider this BC now, here right side anti-clockwise plus, clockwise minus, right? Okay, so VB is going now anti-clockwise. So anti-clockwise is plus. So VB into 10, exactly center, right? VB into 10. Then HB, now you can see here. HB is going now. Okay, you can see here HB. It should always travel along the cable. So HB, it will travel like this. So it is HB into perpendicular distance. So 250 into 4, that is HB into 4. And then 20 into, I was finding at this point. So 20 into 10 into 10 by 2. So we'll find HA and HB, which would be same. Similarly, once you find out, then we'll find moment about A. Now here again, moment about A is your choice, because we already know, because of the symmetry, we already know V and VB. So if you want, you can solve it directly here, or to cross check whatever done is right or wrong, you can use this moment about A. So use this VA and VB and solve this. Okay, if you find moment about A, then you can solve this. VB into 20, which is going anti-clockwise. Then this is 20 into 20 into 20 by 2. Okay, you can always check this. Okay, so once you find out this, now main intention in finding out the cables is you have to find out both here. That is HA, HP, VA and VB. That's it. So once you find the reactions, the next thing is only finding the resultant force. So RA is nothing but it's a summation of horizontal force and vertical force. So HA square plus VA square. So RA, find out the value of RA. You already know both. Substitute this and find. So RA and RB will be same, because it is a symmetrical loading. So RA and RB is same here. So once you find RA and RB, So these are nothing but the reactions. So these reactions determine how much is the maximum tension and minimum tension. So both are same. So that's why tension, maximum tension is also same, minimum tension is also same. We'll write it like this. Okay. Next, we have to find also the length of the cable. So the length of the cable LC is given by, so we know that L total length is, this is length of the beam. Okay. So it is 20 length of the beam, that is the UTL is 20, and height, that is dip, is called as uh, H means it is dip, it's 4 meter. Okay, so now again, length of the cable, we'll always use this formula here. So length of the cable LC is L, means it, you can see here, clear distance L plus 8h square by 3L. Okay, so we have to substitute this L, 8h square, okay, dip square, 4 divided by 3L. So LC is 22.13. Okay, now the difference between L and LC is, you can see here, this is L, A to B, straight length is L, whereas LC is this curved portion. To maintain this dip of 4 and connect this A and B, this is LC. So it is, total length is 20